Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science 2022 Chemistry Paper 1, the Foundation Tier, question number 5. This question is on the chemical changes topic. This question is about salts. Green copper carbonate and sulfuric acid can be used to produce blue copper sulfate crystals. Now, this question refers to the required practical about making salts. So that's why they're talking about making blue copper sulfate crystals. So this is actually required practical that you should have done. So it's about making salts. Excess copper carbonate is added to sulfuric acid. Give 3 observations that you would make. Now, you're reacting a carbonate with an acid. When you react a carbonate with an acid, you get salt plus water plus carbon dioxide. So you're going to see the fizzing. That's one of the observations. Now, the copper carbonate is a green color substance. It's a solid. Now, when it dissolves, it's going to form the blue color solution, which you would later crystallize. So all of these observations can be written down. Let me list some of these observations. Right. Any 3 of these would be fine to gain 3 marks. So it's 3 marks for this question. So a green solid or powder, which is the copper carbonate, a colorless solution, that would be the sulfuric acid, right? A blue solution is formed. That's when it's reacting, it will form the blue solution of copper sulfate solution. The copper carbonate disappears, fizzing or effervescence or bubbles of gas being given out, which would be the carbon dioxide. And eventually it will stop fizzing once all the acid is being reacted, because you're adding excess of the copper carbonate. The solid powder left at the end, or copper carbonate, would be left at the end. All of these are valid observations. I have underlined the 3 observations that I think is the easiest to remember. Question 5.2, how can the excess copper carbonate be removed? Now, if you have excess copper carbonate, which is going to be a solid in a solution, then you would need to filter it. So filtration or filter would be the answer. The pH of the solution changes during the reaction. Now, remember, you are reacting copper carbonate with an acid, so the pH is going to be low. Now, once all the acid reacts, the pH is going to change, and eventually when all the acid has reacted, what you're going to have is a neutral solution. So what is the pH of the solution at the end of the reaction? The pH, because it's a neutral solution, is going to be 7. 5.4, copper carbonate and sulfuric acid react to produce copper sulfate. Right. So that's the product that is actually being formed, the copper sulfate. What type of reaction is that? This is a neutralization reaction. Now, during this reaction, you would also find that heat or energy is given out. So it's also an exothermic reaction. So saying it's a neutralization reaction is better, right? It's easy to remember. Question 5.5. Ammonium nitrate is a salt. Figure 3 shows the maximum mass of ammonium nitrate that can be dissolved in 100 centimeter cube of water at different temperatures. So on the y-axis, you have the maximum mass of ammonium nitrate that can dissolve in grams per 100 centimeter cube of water. So, and on the x-axis, they have given you the temperature, which goes from 0 to 100. And you can see the graph, the mass of ammonium nitrate that can dissolve is increasing as the temperature increases. The student adds ammonium nitrate to water at 80 degrees until no more dissolves. The student cools 100 centimeter cube of this solution of ammonium nitrate from 80 degrees to 20 degrees to produce crystals of ammonium nitrate. Determine the mass of ammonium nitrate that crystallizes on cooling 100 centimeter cube of this solution from 80 to 20. Now, going back to the graph, you can see when the temperature is high, more of the ammonium nitrate is dissolving. What happens when it cools down? Well, less should actually dissolve, right? So the rest of it is going to crystallize. So how much is actually dissolving when it's at 80 degrees? So at 80 degrees, if you go all the way up, right, to that point, that's about 1.5 boxes from this solid line. So that's 80. Each box is 2, so 1.5 boxes 83. So at 80 degrees, 83 grams is dissolving. So let's write that down. At 80 degrees, right, 83 grams dissolves. So what about at 20 degrees? You would use the graph again. So if you go back to the graph, so you have 20 degrees there, and that's roughly about just one box. So that will be about 32 grams. Let's say 32 grams dissolves here. So the difference between those two numbers is 3 minus 1 is 1, and 8 minus 3 is 5. So 51 grams of the salt would crystallize. So 51 grams. That brings us to the end of this question number 5. I will see you in question number 6.